Hi students, this is Sumit Kundu here. Okay, you're watching me live here in today's session. So, you're watching me live here in today's session. So, dear students, just give me a second, 2 minutes. Just give me a second, 2 minutes. इको आ रहा है. नो, कहीं पे कोई माइक. So, hi everyone, I'm back here. Hi Manish, hi Anuj, hi Kale. Alright, so all tense guys, before the exams, they're just round the corner. Okay, so good evening Amar, good evening Shanta. There's so many of them saying hi out here. Okay, that's great. Vedant, Chandak, yo sir, tension free. That's how you should be like. Right now, बच्चों, जो होना था preparation actually हो चुका है. Now it's time to relax basically. Alright, fine. Students, we have started this 15-day sprint to JEE Mains, as all of you must have appeared for most of the sessions, and based on your requests and demands for your thermal physics and thermodynamics, we are kind of launched this session here for your thermodynamics and thermal physics. Okay, my name is Sumit Kundu. Hi Narayan, how are you? Okay. Sir, please can I send the doubts through WhatsApp, sir, please? Yes, not through WhatsApp. I'll tell you how can you send your doubts. Okay. Now, students, in today's session, what we are going to do, I'm telling you first. In today's session, primarily, I have divided the thermal physics into two parts, in which in the first part, we are going to, that's like, you know, your part 1 out here. We are going to talk about your questions, that is your previous year's questions on calorimetry. Then we will have thermal expansion, and finally we are going to look at a few problems on heat transfer. Alright, so this is what we are going to cover in your thermal physics 1. Alright students, okay. Now, few important things before I can get started off with the session. Again, let me tell you, tomorrow I will be taking another session on thermal physics 2, where I'll be talking about your indicator diagrams and various processes which has got a greater weightage. Clear? Now come to this point here, students. Yes, I can see all your comments, latent heat, and when do optics start, sir? Sumit Sir rocks, your crash course on LLM kinematics, sir. Great, sir. Thanks a lot, sir. Narayan, thanks a ton for the appreciation. Okay, chalo, let us go. Just a second. Let me just close this. Yeah. So students, for a lot of you who have not attended the mock tests, if you can observe that these test 1, test 2, test 3, they have already taken place. So in the description box along with this video, you will be having these links. So you can just go to those links and prepare, like, attempt those tests. They are like, give you the round feel of the JEE Mains examinations before the real examination. Okay, now for this, the mega mock test that is supposed to be tomorrow from 9:30 to 12:30 and again from 2:30 to 5:30. So let's say you miss out in the morning at 9:30, you can also appear for it in the afternoon, that is from 2:30 to 5:30. What do you need to do? See, for this you click on it, you can go to the tests and practice the tests. For tomorrow's one, when you click on it, it's not going to redirect you to, listen to me, focus. It is not going to redirect you to a test. You have registered. Then you will receive another mail. Alright, students? And the mail that you receive after that, the directions will be given. How are you supposed to attempt that particular test? Okay? No, this is going to be a new test, a brand new test. Now, 9:30 to 12:30 and 2:30 to 5:30, they are going to be two different tests. They are not going to be the same test. So in case you want to appear for both the tests, you are most welcome to do that. Okay, guys? All right. Excuse me. Okay. So let's get started here. And definitely, students, do not forget to like, share and subscribe after you have watched the session here. And chalo then, now let's get started here. Students, this is kind of a very important slide which I thought I'll be sharing with you. Alright, if you look at here, starting from 2007, based on whatever topics that I have just told you, alright, that is calorimetry, thermal physics, that is thermal expansion, and also your heat transfer. If you see clearly the weightage, I mean, this is like, this one is for JEE Mains, this is for JEE Advanced. The weightage have increased in the recent years. That is 2016, there were 3 questions which was coming from this particular topic. All right. So definitely it is a very, very important topic that you must be focusing on, my dear students. All right. So moving ahead. First, we will look at calorimetry. Now, students, they say JEE Mains questions don't get repeated. Alright. However, I beg to differ in a way. JEE Mains questions, they don't get repeated. I totally agree. Alright. But let me tell you, concepts, they do get repeated. There are certain trends, alright, which we teachers at Vedantu have identified, and those are the kind of questions that I'll be doing with you and try to show you that how certain trends, they get repeated year after year. Alright, so we will take our first questions on calorimetry, right? Now here let us look at this problem. It is talking about that there is a water of volume 2 liter, okay, water of volume 2 liter in a closed container in a heater with a coil of 1 kilowatt power. Okay, so let me just get the pen mode started here. So I have got a vessel, let's say. So let's say this is my vessel, and in the vessel definitely there is water. So I have kept water inside the vessel, and the total volume is equals to 2 liters. Clear? Now inside this vessel there is also a heater which has got a power of 1 kilowatt. Clear? So it's got a power of equivalent to 1 kilowatt. So let's say I have kept any heater out here and that's giving me a power of 1000 watt. Clear? Now while the water is heated, the container loses energy at a constant rate. So the container is also like, you know, there is loss of heat to the surroundings, as we can say. So some of the heat is getting kind of lost out here. Okay, and it is losing at the rate of 160 joules. Just a second. 160 joules per second or 160 watt. All right. Now they are asking us in how much time will the temperature of the water rise from 2 degrees centigrade, or let's say, all right, actually there is, okay, say from 2 degrees centigrade to 77 degree centigrade. Clear? So the change in temperature, that is your delta T, is from 2 degrees centigrade to I beg to differ, students, there is a slight correction here in this. All right, since I am pretty much aware of what the actual question is, it was actually 27. So it goes from 27 degrees centigrade to 77 degree centigrade. So the delta T is equal to 50 degree centigrade out here. All right. So overall, this is the premise of the question, that how much time it is going to take. Now listen, this is the question which appeared for JEE Mains Online 2014. Okay. Now let us look at the solution. It has got a one-liner solution, very simple. All right, and this same type of question has appeared for 2015 as well. So that is what I want to actually highlight. Okay, in calorimetry they are going to provide a heater, so that combining these two things, like, you know, that heater is going to provide some energy, then how are we supposed to take that particular thing into consideration in order to find out my answer. Okay, so how much heat is going to be required in order to go from 27 degrees centigrade to 77 degrees centigrade, my dear students? Okay, that is very simple. I think it is nothing but mass. Now first thing, what is the mass of the water? It is going to be equals to density into the volume. Now what is the density of water? We know is 1000 kg per meter cube. All right, so it is 1000 kg per meter cube into the volume of water out here is 2 liters, right? So 2 liters is equivalent to 2 into 10 to the power minus 3 meter cube. All right, so 2 into 10 to the power minus 3 meter cube. All right, which is going to give me nothing but the total mass is 2 kg. All right, students. Then yes, Rohan, hey, fine. So that mass is equals to 2 kg. Then delta Q, that is the heat required in order to go from 27 degree to 77 degree, is going to be equals to mc delta T, which is equal to nothing but the mass is 24200. All right, and change in temperature is 50. Clear? Now the important part, students. Okay, the important part out here is that this much amount of heat, that is delta Q, is to be supplied by the external source, that is your heater. Okay, now as the heater is supplying this particular heat, now not just the heater is supplying heat, but it is getting lost also at 160 joules per second. So the net amount at which the heat is coming to this water here is 1000 minus 160, and let's say it is supplied for T time. So this is the net energy that is provided by the heater. Okay, plus taking into consideration that some energy is getting lost to the surroundings. So students, combining both of these together, what do I get? 1000 minus 160, 840 into T is equal to 2 into 4200 into 50. Students, if you solve it, 2 into 4200 into 50 divided by 840, you are actually going to get, the calculation part I'm going to leave it to you guys. Okay, it's not a very difficult calculation, and you will get option A as the right answer. Fine. I hope, did you all understand? Sir, can you please repeat? Will you repeat again? Okay, I'm going to repeat. Chalo, let's see. What have we done? We know in order to raise the temperature of this liquid out here, we need some heat. Clear? So, the amount of heat required, all right, is equal to, given by this formula here. Focus now, all right, out here. So, the amount of heat required is going to be given by this thing. All right. Now, who is providing it that heat? The heater. All right. Now, the heater is providing the heat, but the heat is also getting lost to the external surrounding, my dear friends. All right. So, the net rate at which the heat is coming to this water inside, I mean, it's coming to the water inside is how much? 1000 minus 160. So, overall, this becomes equals to nothing but 840. All right. That is equals to 840. So, 840, let's say it gets heated, for time t. This should be equals to whatever is the heat required to go from how much? 27 degrees centigrade to 77 degrees centigrade. Okay. Now, you just solve it, you will get this as your answer. Now, did you understand it? I hope everybody is got it right now. Isn't it? See, my dear students, in lot of times, this particular thing used to come into my mind as well. Like Celsius and Kelvin. Okay, Celsius and Kelvin doesn't make much of a difference when it comes to, say, in heat and thermodynamics. Primarily, most of the times, listen to me, most of the times what happens is we are talking about change in temperature. So, delta T, whether it's in degree centigrade or whether it's in Kelvin, it is the same thing overall. Okay? So, it doesn't create much of a difference. So, if you are getting something in Kelvin, even if you write it in degree centigrade, it is going to remain to be the same. Alright. Chalo guys, let's go to the next question. Alright. Now, here in the next question, we have something very, very similar. Observe, this question had come for JEE Mains. I'm taking like the online papers. Generally, I've picked up most of my questions from the online papers. So, this is in 2015. Alright. So, for 2015, there was this question, again, heater based calorimetry problem. Clear? The idea and the concept was the same, my dear students. An experiment takes 10 minutes to raise the temperature of water in a container. So, here also I had a container. Here also I had a container. And in order to raise the temperature from 0 to 100, from 0 degrees centigrade to 100 degrees centigrade, alright, it actually took how much time? 10 minutes. Alright. So, overall time was taken as 10 minutes. Alright. Now, another 55 minutes to convert it totally into steam by a heater. Look at that. Again, same concept, by the heater. Supplying heat at a uniform rate. That means, let's say that this heater was present again into this water. Alright. And let's say the power of this heater let's say the power of the heater is equal to P. Okay, then it took 10 minutes. That means power into 10, sorry, that was like 10 minutes. Power into 10 minutes is equivalent to the heat required by the water to go from 0 degree centigrade to 100 degree centigrade. Clear? So how much time will it take? 10 minutes. Power is P is equal to, let's say the mass of the water present inside this is M. This is equal to M. Alright. We know its specific heat capacity is how much? 1 calorie per gram per degree centigrade. Okay. Into how much is the change in temperature? 100. Right? So power into 10 is equals to mass mc delta T. That is what we have applied here. Alright. Next, same heater working for 55 minutes is going to evaporate all the water into steam. Are you getting it? Is going to evaporate, right, Prasanna? 550 is the answer. But what happens, I'll tell you, when they ask us about the latent heat of vaporization, the mind quickly goes to 540. So I have used this question multiple times and 60% of the students choose this because they have already memorized that the latent heat of vaporization is 540. Yes, Dalveer, Adi, Deepak, Pradeep, Gamer Pro, all of you are giving me the right answer. The right answer is 550. You guys are well prepared for your JEE Mains, it seems. Okay, good job guys. Chalo. Now let me just finish this. For the ones who are still watching and trying to follow it here, watch it. Okay. So power into 55 for 55 minutes is going to be M into the latent heat of vaporization. Equation number 1, equation number 2. You know what to do. Divide equation 2 by equation 1. You will get your answer. Okay. You will get the answer as 550 calories per gram. Happy New Year, Vijaya Lakshmi. By the way, yes, Happy New Year to all of you. Okay. I hope this new year brings good news for a lot of students who are watching this particular video. All right. Thank you, Guru. Okay. Chalo, let's go to the next question, my dear students. So did you see 2014, 2015, the same question kind of got a same trend wise question got repeated. All right. So that kind of creates a difference. All right. Definitely the question as it is did not get, but this concept of power into time with calorimetry concept of MC delta T got actually repeated. Fine. So let us move ahead to the next question. This one, 5 gram. This hasn't repeated in any of the years. I've got a very high expectation from this question and to be coming in one of the exams for sure. It's an easy one. It's not very difficult, by the way. All right. What do we have? 5 gram of ice at 0 degree centigrade. Okay. 5 gram of ice at 0 degree centigrade is mixed with 5 gram of steam at 100 degree centigrade. What is going to be the, yes, Shalu, you can ask me your doubt. What is going to be the final temperature of the mixture? Okay. Vedant, I'll tell you about that in some time. Narayan, good job again. Yours is the right answer. Okay. Chalo, let me tell you. We've got ice. How much? 5 gram of ice. So chalo, we have got What color do you like? Do you like black or red? I'll use that color ink. What do you like the most? Black? Fine, we'll go ahead with the black. I can see most of them are saying me, oh, it's a group mixture. So it's black, red, red and black, red and black. Okay. Right. Guys, let me tell you, these concepts, if you have understood this question, okay, I get you. It is red. Red is your priority. Okay, guys, it's not Valentine's Day anyway. So anyways, but still red is your priority. Fine. 5 grams of ice at 0 degrees centigrade is mixed with 5 grams of steam at 100 degrees centigrade. All right. So 5 grams of ice, if I have to take it from 0 degree to 100 degree, what do I have to do? 5 grams. Beta, Carnot cycle tomorrow, Shalu. Okay. 5 grams from 0 degree centigrade to 100 degree centigrade. See, first of all, ice, I have to melt it, right? So in order to melt this much amount of ice, what do I need to do? 5 into 80. 80 is the latent heat of fusion. Plus, in order to take it from 0 degree to 100 degree, how much heat supposed to provide it? It is going to be 5 into 1 into 100. All right. So this is going to be your 400 plus 500. Overall 900 calories is required in order to melt 5 grams of ice and then take it from 0 to 100 degrees centigrade. All right. Now, I have got 5 grams of steam at 100 degrees centigrade. If all these steam was to convert or condense into water, then how much heat is it going to liberate? 5 into 540, which is nothing but equals to m into latent heat of vaporization. Clear? Which comes to somewhere around 0, 5 4s are 20, 2700 calories. Now you just need to check and understand these two data, that is 2700 and the next one is 900, my dear students. Okay, 2700 and 900. Yaar, in order to go from melt ice and go to 100 degree, I need how much? 900. Okay, now if 5 grams it converts to 2700, I don't require, I require 900. So in order to do that, all the steam need not get converted into water. So if steam is there and we have come 200 degree, then the final temperature will be 100 degree centigrade. Okay. Now students, there are certain questions in which बच्चे रोटेशन तो अभी हम कर नहीं रहे ना नारायण, but if you have any doubt, I'll tell you, my dear students. Okay, just give me a second. See, this I think everybody has understood. No repetition is required, I think. Okay, यार Anirban, चाहिए repetition? Just one small thing I'll tell you. 900 calorie required to melt it and take it to 0 to 100. Now all 5 grams. Now for the steam, if all the 5 grams were to convert it into water, 2700 calorie it will give out. Okay, 900 chahiye, 2700 is coming, but 2700 is not required, 900 is only required. So all the steam is not going to convert into water. Get it? Simple idea. All the steam is not going to convert into water, so steam is going to remain and all that 5 grams of ice is going to come. Is this clear? So final mixture will have how much, if they ask you the final composition of the mixture, that is your homework. Okay, students, solve it. Like, homework is going to be find the composition of mixture. that you can do it. Okay? Alright students, I think that is pretty well done. Now what we are going to do, by the way, a lot of people have certain doubts that they are asking me, sir, if I have doubts, what do we do? Okay, I'll tell you. If you have doubts, see students, I had forgotten to mention about this thing. Join the study group. There is a study group in Telegram, okay, vdnt.in/study group, wherein if you post any of your doubts, there are so many students who are so active over there, the teachers at Vedantu and a lot of other people. You can get all your doubts clarified out there. ठीक है? Dhiman Singha, you are correct. Absolutely. Good job, Dhiman. Alright. And also, regarding this lecture, the questions that I have taken, that is going to be available in this link, okay, the 15-day sprint videos plus question list. So whatever 7 to 8 questions that I have taken for today's session, that is going to be available. All right, so you can do that. A lot of people are asking me, that I can see. Guru Sharan, ऐसा कुछ नहीं है. Online is difficult than offline. Okay, and we are giving you the maximum practice by taking up these tests. All right, which is going to make you feel as if you are there for your real examination. All right, chalo, let's move ahead. So take this test very seriously, students. They are going to give you the real feel. On the day of the examination, you will feel that you are writing another mock test. Bas, that's it. Okay, chalo. Thermal expansion. This is a very interesting question. It appeared in the year 2017, very recently. Students, now focus. Okay, see, what are they saying? We've got a cube. चलो एक cube draw करते हैं यार, ठीक है? So let us draw a cube here. Wow, looks like a beautiful cube. Now there is pressure applied to this cube and it is equally from all directions, as a result of which it is getting compressed, right? Satvi, Vijayalakshmi, Ajay Verma, Tharun, good job guys. Okay, answer is definitely option C. You guys are well prepared for your JEE, boss. Aryan, मानना पड़ेगा यार दोस्तों. Okay, chalo, let us understand the concept, and they have done it repeatedly number of years, this particular concept. Okay, Falak, true. Preeti Jain, absolutely correct, all of you. Chalo, now pressure was applied all directions. Now what do we know? Bulk modulus is equal to, bulk modulus is equals to P into delta V by V. Alright, which tells me from this equation I can conclude that my delta V by V will be equals to P divided by K. Alright, this is for the compression part. Now here, suppose we want to bring the cube to its original size by heating. Then the temperature should be raised by how much? So first of all, due to pressure, it is getting compressed. Okay, and then we are trying to heat it up in order to bring it back to its original volume. Okay, then for heating purpose, we know V is equals to V naught into 1 plus gamma delta T. Alright, which implies I can write down my delta V by V, alright, or here V naught is nothing but equals to gamma delta T. So this is my equation number 1, this is my equation number 2. Alright, now let me draw a line here, and then I can just equate equation 1 to equation 2. I'll get my answer. Very simple. Alright, so what I get, P divided by K is equals to gamma delta T. They have asked us for this. So delta T is going to be equal to P divided by gamma into K. We know gamma is equals to 3 times alpha. P divided by 3 alpha into K. This is the answer. Okay. Yes, option C is the right answer. And some of the students said D. No, D is not the right answer. Definitely, because it's just alpha out here. Okay. So good job, guys. A lot of you have given me the right answer. Looks to me that you are pretty well prepared. Now, the most important thing out here is to go and understand that another question which appeared for 2017. Now, this was a different set of paper. That was an offline paper, and this was an offline paper 2017, and this is a online paper of the same year. Okay. Now, what is it? Let me explain to you the premise of the question out here. There is a compressive force F which is applied at the two ends of a long, thin steel rod. Alright, so it is applied there. Now, it is heated simultaneously such that its temperature increases by delta T. So, there it was cube, and you are applying pressure from all directions and you had to heat it. Because of the pressure, volume decreases, and because of the heating, volume finally increases. So both were equal. Okay, here concept is the same. There is a rod, you're applying force. All right, you're applying force, and because of heating, its temperature is increasing, because of which the length is going to increase. Alright students, the length increases. Wow, both of them get equalized. Finally, there is no change in length. Okay, now let's see what happens here. They have given to us its Young's modulus. Just a second, guys. They have given to us its Young's modulus, that is defined to us. It's Y. They have given to us its area. Alright, and they have mentioned that the change in length is 0. There is no change in length. Alright, let L be the length of the rod. That is also specified to us. Now, look at it. Very simple. How do we go about? Young's modulus is force upon area into delta L upon L. Stress by strain. Very simple. What do we do here? Did they mention to us what the area is? Yes. Did they mention to us what the force is? That is what we are supposed to find out. We got it. What is delta L out here? Now we can find it out. Okay. Now this quantity here, delta L by L. Now this is from the part where we are applying the force. Clear? Students, focus. We also know my delta L by L is nothing but equals to alpha delta T. Now here delta T is given to us. Equation 2. Take down the value of delta L by L from here and insert it out here. Okay. What are you going to get if you do that? You're going to get Y, or Young's modulus, is equals to F divided by A into delta L by L is alpha delta T. Alpha delta T. That means how much force should I be applying? From here, F should be equals to YA alpha delta T. Alpha delta T. So this is my answer, dear students. Okay. So here it is going to be option C. That is the right answer. Oh my goodness, I was just solving and people were already giving me the answers out here. Good job, good job, good job. Yes, Abhishek, C, 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 C. Yes, I saw that. I am seeing it. Right, guys? Chalo, let's take up the next question. And it gives me a feeling that thermal physics, this is one of the most repeatedly, like, appeared concept that has come. Okay, chalo. 1, 2, 3, let's go to the next question. And before that, let's remove this. The length of the question is pretty huge, quite lengthy. Now what I'm going to do, it's not tough, okay? Everything is easy as long as you can master the concept, all right? And we here at Vedantu master teachers, we kind of only focus on the concept, okay? Now here what they have told, you don't have to read this entire thing, students, but this is for your reference sake. Whenever you take it later down the line, people should be able to understand what were the questions. Okay, we've got a wooden wheel, circular wheel, wooden, where they have kept a gap in between. You see that? Excuse me for that. They've kept a gap out here. All right, students. Now, the cross-sectional area, now they have taken a metallic strip in order to compress that two wooden wheels. Is this clear? Now, let us see if your answer is correct. I will not tell you anything about it right now. Let's go ahead. Okay, students? But I like the energy that you people are showing. So this metallic strip which is there, it is going to bound it. All right. Now, they have asked us, what is the force that one part of the wheel applies on the other? That is what we are supposed to find out. Okay. One part of the wheel applies on the other. Is this clear? So, we are going to start with the same concept that we are seeing. Young's modulus, force upon area. Now, if we increase the temperature by delta T, clear? What happens? Like, this ring has got a length little bit lesser than the circumference of this. But what I do, I increase the temperature of this ring. All right. I increase the temperature of the ring so that it expands and it can well fit into this particular thing. So this, what I am doing, it is basically for the ring. So as it is being heated, its Young's modulus is Y. So they have given to us, say, the force that is being exerted by, the force that got generated because of that, or the stress that got generated due to heating of this. All right, students, I can write it as F upon S, because the cross-sectional area is S, all right, divided by the change in its length. What is the length of the ring that is supposed to change? Observe here carefully, delta L. Students, this delta L is going to be equals to 2 pi into delta R. 2 pi into delta R. All right, students. So I can write here the change in length is 2 pi delta R divided by 2 pi into R. 2R pi. That's what it is. Clear? So this is overall the equation for the ring. What I can do is 2 pi will cancel. Young's modulus will be Fr divided by, or I can write it as Fy is equals to F divided by S, here delta R upon R. Makes sense to all of you? Okay. Now, very simple. What we need to do is we need to find out what is going to be your delta R upon R. We can find it out from the equations out here. It is nothing but equals to alpha delta T. Very simple. Okay. Delta R upon R will be equals to alpha delta T. Very simple. We have already studied that. So we can say that force will be from here Young's modulus into S into alpha delta T. But will that be the answer, my dear students? No, that will not be the answer. My mistake. Why did I remove all that? Okay. I shouldn't have done that, by the way. Okay. So we got, I remember the thing. We got F is equals to YS alpha delta T. But is this the final answer, my dear students? Come on. I need the, so please give previous year's question topic wise. Okay, sure. We'll do that. No. See, the force that one part of the wheel applies on the other is coming from both the ends. It is coming from both the ends. As a result of which, the net force is going to be equal to 2 times this force that has got generated, which will be equals to then 2ys alpha delta T. My dear students, option D happens to be the right answer then. Clear? Alright. Guys, since I already rubbed it, I'm not going to write all that right now. Please watch the recording. That is also going to be available. Okay. So what I want to stress on, my dear students, is the very fact that are you able to see the trend? Are you able to see the synergy that different years are having? Okay. There was the same concept that got kind of repeated. That is what I want to showcase to you. All right. That is kind of more important than actually getting to know the solution of this question. All right. Chalo, let's kind of move ahead to the next question. Now here, my next question is going to be on transmission of heat or heat transfer. It's a very easy one. Now this one gets repeated pretty often. For heat transfer, this is the one. You people solve it and tell me the answer. I'm not going to solve it now. Short tricks तो इसमें apply कर सकते हैं, बिल्कुल कर सकते हैं. We can easily do it. Okay, I'm kind of watching your thing out here. What do you say? B is the right answer or A is the right answer? See, so how much time should you take it? Alright, see, the ultimate concept that we have here, listen to me now. I can see all your responses over the chat. Now listen to me here. What we do here is, they have asked us to find out the junction temperature, that is your T. What is the temperature at the junction? Clear? Now we know whatever is the heat current flowing through this is going to pass through this. All that you are already aware of. Day after tomorrow is the exam. Okay. So let's say this is H1 and this is H2. So we know for sure that my H1 is equals to H2. Now when I write down the equation, I will be able to figure out what is the answer just at one go. Let's see it. How? So what is going to be my H1, my dear students? Ka, that is K1, A. What is the temperature difference across here? T1 minus T. Divided by, what is its length? L1. Should be equals to K2 into A, T minus T2 divided by L2. ठीक है? अच्छा. If you look at this very carefully, my dear students, if you look at this very carefully, from this only you don't have to solve any further. See how? K1 is going to go with L2. So look at in the options, where is K1 there with L2? K1 is there with L2 in option D. K1 is with L2, no, not here. K1 is with L2, no. K1 is with L2, yes. It is out here also. But K1, L2 and T1. K1, L2, T1 is only present in option D. Bas, that's it. You got the answer. Okay? Excuse me. Yeah. So, that is your answer, option D. It didn't even take me even 30 seconds to get this correct. Acha, there is no green pen. Okay, fine students, I'm not gonna, is it like, you know, not visible? Okay. Sir, how do you know both the sections have equal areas? Because it is pretty much visible from the diagram that both the sections have got, yeah, great. I'm going to use black or red, that's it. Okay. So, remember, if you want me to overwrite it, I'm going to do that, guys. Don't worry. I'm going to write it with black, okay? Fine, I think it's pretty clear to you, all of you right now. Okay. Fine. Students, I hope everybody got that particular thing. Now, this was which year? 2007. The year I passed out of IIT Bombay. Okay. Sumanyo, पार्टी कब दोगे जब आप जेई मेंस में अबव 250 लाओगे? प्रॉमिस पार्टी फ्रॉम माय एंड. बाकी इतने सारे लोग देख रहे हैं, जस्ट मार्क माय वर्ड्स, इट इज गोइंग टू हैपन. ओके. यस, देव पटनायक, आई एम अ बंगाली एंड आई लव फिश. ओके. यस, चलो, लेट्स मूव अहेड स्टूडेंट्स. लेट्स गो टू द नेक्स्ट क्लास, नेक्स्ट क्वेश्चन. नाउ हियर in the next question, very similar. Tell me in 2 minutes what is going to be the answer. The only thing that I wanted to show to you, concepts get repeated. Online, May 19th, 2012. Okay, so this is pretty easy. Omkar Joshi, if you don't get into IIT, life doesn't end out there. That's one of the best things is. Okay, so guys, you just learnt a formula, apply it directly from there. Didn't you learn the formula? Just now you got that. K1 T1 L2 plus K2 T2 L1 divided by K1 L2 plus K2 L1. Temperature of the junction. There is a formula out here. Okay. So just put down these formulas. We know thermal conductivity of copper is 9 times that of steel. So let's take this as steel. Let's take this as copper. So steel, let's say the conductivity is K. Temperature. So which one is maintained at 100? That we need to take into care. A large cylindrical rod of length L is made by joining two identical rods of copper and steel of length L by 2 each. So I have got L by 2 here, and along with that another L by 2, L by 2, L by 2. This entire thing is like L. Okay. Now the rods are completely insulated from the surroundings if the free end of the copper is maintained at 100. So this is your copper at 100. And this is steel, this is at 0 degrees. So I am taking this part as steel, alright. So I can see it very clearly that this is nothing but K, T1 is nothing but 0 degrees, keep it as 0, okay, K1 L2, so K into 0, 0 gone plus basically, take care. And then we have this part as 9 times K into temperature is like 100. All right, length is nothing but L by 2, and this is going to be divided by completely K1, that is nothing but K. L2 is again L by 2 plus this is going to be 9 times K. All right, length is again L by 2. Clear? L by 2, L by 2, L by 2 will cancel thoroughly out here. K is going to go. So this is 900 by 10, that is 90 degrees centigrade. So option A is the right answer. Clear, guys? Fine, guys. So one last question for today's session. All right, and just to give you the ultimate boost and the confidence that lot of you I can see here are very well prepared, and it is one very easy topic and scoring topic, my dear students. Okay, and in tomorrow's session we are going to look at the part which is like, you know, has got more weightage in JEE Mains and advanced. Okay, that is laws of thermodynamics and entropy and your like, you know, not enthalpy for sure, and then you have got your Carnot's engine, Carnot cycle and everything. So that all that comes into the picture out there. Okay, so let's proceed ahead to our today's last question. Srihari, afraid of what? This one, and this question came in 2009 in the offline paper. Vinayak Kapse. Okay, Kapasi, is it? Okay, whatever. A long metallic bar is carrying heat from one of its end to the other end under steady state. Clear? Steady state, the variation of temperature theta along the length x of the bar from its hot end is best described by which of the following figures? What do you say? Dalveer, absolutely correct. Good job. Set hai boss tu. Okay, now let us look at how do we get it very quickly. Let's just prove it. We'll take up a bar here, and we know that, my dear students, dq, or let's say heat current, is equals to Ka theta minus theta naught divided by x. Clear? Arrange this. What do you get? Theta is equal to, we will get nothing but equals to hx. All right, this is going to be minus, basically, if you look at it, because the temperature, this part, temperature decreases with the value of x. All right, students, so we are going to get minus, just a second, minus h by K A into x plus theta naught. Okay, so from that equation this easily comes into the picture. Now what do you see here? A graph in which it has got a negative slope. So this has got a negative slope. Linear equation and negative slope. Yes, option A is the right answer. Okay, chalo guys, that's it for like our today's session. All right, let me tell you few other things which is kind of very important from this particular section. All right, now what are those important things which are important? Remember, students, Newton's law of cooling has appeared or surfaced in the examinations for the maximum number of times. Now, while we are doing Newton's law, there has been a favoritism that we are going to do by the average temperature method, and we don't use the log method. Log method is very important because you never know whether the question is going to come from the log method or come from the general method, that is the average or the mean temperature method. Okay, second thing. Third thing, wait, let me just tell you a few important concepts which is kind of very important. Let me just remove this. Okay, so this is come here. Okay, now students, remember these. Number one, Newton's law. Both average method and the log method, both the equations should be handy with you. Okay, number 1 point. Second thing, Stephen's law. When you have learnt, Stephen's law is another very important thing. Okay, focus here. Now in Stephen's law, whatever is like, you know, the MSF power and everything that you get, or Q is equals to E A sigma T to the power 4. Some of the students, you should always be aware that we also need to consider the surrounding temperature as well. Okay, so if the surrounding temperature is T naught, so you need to consider this as well. Clear? So sometimes there are questions in which the surrounding temperature is given and students, they don't know how to use that particular thing. All right, fine. Other than that, everything else is set. There is Wayne's displacement law, and there were few questions in the previous years in which Wayne's displacement law was clubbed together with the Stephen's law and questions were asked. But again, even if you know the basic formulas, it is going to be enough. There is nothing much that is expected more than that. Okay. Acha. Another thing, moving ahead, students, very importantly, we're going back, let's go forward. Very importantly, I came back to this slide once again. See, ultimately, tests and practices are what is required now and what is important right now. So these three links, if you have not taken the test, you can go there for the practice. And about this one, register for it for today itself for your tomorrow's test. Mega test gives you the grand feeling of JEE Mains. All right, students, and then join the study group, and all the questions that I have taken up today is going to appear in the link below. I hope you enjoyed today's session, my dear students. Did you like spending time with me? And finally, like, share, subscribe. Okay, happy birthday. Today is your birthday. No, my birthday is on 3rd of July, and that is yet some time to come. By that time, you will be busy with the admissions into your engineering colleges at that time. Okay, or your results of 12th standard would be coming out. So you can just link that time to my birthday and you can send me a personal message. Okay, fine guys, God bless you all. Take care. Bye bye. Do not forget to like, share and subscribe. All right, and do not forget to subscribe to the test for tomorrow. Okay, God bless you all and best of luck. And in tomorrow's session, again, I'm going to be teaching your thermodynamics, laws of thermodynamics, indicator diagrams, how to solve it faster, and a lot of tricks out there. Shihari, I wish I could continue, but yes, there are times that we need to say bye-bye. Okay, fine guys, take care. God bless you all.